What's good, guys? Welcome back to the channel. So this is the first video of this year of 2022. It's actually the end of February as well when I'm doing it. So I'm back. I've been sat on loads of old content which I've been putting out, which I hope you've been enjoying. But yeah, I took about 6 months off being on the tools as an electrician to renovate and start my warehouse for loadout for the tool business. So yeah, lots involved with that. It still takes up a lot of my time, but yeah, I'm hoping to get back on the tools a bit more now, keep doing what I love, which is electrical. I'm not getting out of the game just yet. I don't want to get out of the game, but yeah, my tool business just required a lot of attention to get it off the ground, get it through this next phase. Today we are doing some earth electrode testing with the one and only Paul Meenan. So yeah, Paul's been offering to help people out. I've taken him up on his offer. Paul's a nice guy, I've met him before. I'm looking forward to it. I'm heading over to a station in Essex, so that'll be cool. Can't show you too much of that, more about the process and the knowledge today. But yeah, it should be interesting. I've never done earth electrode testing. It's something that's always fascinated me. I've always wanted to know more about, but I've just never done. So the fact that I can get taught by someone who, you know, not only knows it in and out, but is a very good teacher, is going to be cool. So yeah, hopefully I can show sort of Paul showing me, and then I can gain that knowledge hopefully, and then underpin it a little by showing you guys myself. Hopefully that's a plan. It might not go to plan, but yeah, that is a plan. I think there's some other people there today as well, so I don't want to be, you know, stepping on anyone's toes and waving my camera in anyone's face and stuff like that, because ultimately today is about sharing knowledge and learning something. So yeah, before we get into the video, if you haven't already, please like, subscribe, hit that bell button. Check out the Loadout YouTube channel as well. That's in full force now. So if you're into electricians, tools and equipment, there's loads of videos coming out on that channel. Loads have been out already. Put a link to that below. And also check out Loadout for any tools, for any technical trades, but especially if you're an electrician, make sure you go check that out too. I'll head over. I've got about an hour's drive. But yeah, I'll catch up with you guys once I'm on site. Right, so I've been here a couple of hours. Paul has kindly taken me and a few other guys through all three methods of earth electrode testing, so that's been really informative, really insightful. We've also just been like chewing the fat and yeah, having a bit of a laugh on that, so it's been nice. A couple of guys have gone. Will's still here, so Will from Will's Electrical Services, I'll put his channel below. He's a legend. He's been here today as well. He's just here, looking at some stuff about earth electrode testing and earth leakage testing with Paul, and I just thought I'd walk the route and show you what's going on. I'm going to try and show all three methods. I sort of have quite a far better understanding of them now, but I'll probably do it alongside Paul so that you guys can get, you know, a great insight into it. But yeah, what they've done, put a new electrode system in. They've actually gone for discs, so the earth discs, which is quite cool. I'll get Paul to explain that because the process of that is insane. But yeah, you don't obviously have to drive the stakes in anywhere near as deep. There's a lot more of them though, so there's 9 discs. They come from the switch room, which is where that door's open there, and then yeah, they come along here. You've got one, I believe, in and around here. They're sort of marked by these pits, so obviously there's nothing below this pit because the discs are buried in the ground, but these are just essentially markers for where the discs have been placed. So we've got 1, 2, 3, you can sort of see them, there you go, 4, 5, 6, 7, 7, can't see any more. Maybe these are buried here. But yeah, so there's 9 of them anyway. We're gonna start by doing the proper method, so putting the stakes in and testing like that. Then we'll do the clamp method, which is super cool with the mega clamps, and then we will do the ZE method, the easy method. But yeah, hopefully it's informative. Hopefully you learn something. I certainly have today. But yeah, I'll go catch up with Paul now. So I'm with Paul now. I'll let him talk you guys through what we're doing. Here he is. This is one of his switch rooms. So Paul,
can I just say, what is good, guys? I don't know. I have no idea what that even means. But there you go. What is good, guys? I've always wanted to say that. Sorry. Right. Okay. So what we're doing, we're in one of my switch rooms, and what we're going to do is, in this location, we have got a earth electrode farm, effectively. So when people do earth electrode testing, we normally just do an earth loop, ZS testing, and that's it. However, if we look at the wonderful guidance note 3, there's 3 methods in guidance note 3, page 60, test method E1, E2 and E3. E1 is called measurement using dedicated earth electrode tester. Dedicated earth electrode tester. E2 is using stakeless or clamp test.
These are really cool.
Which are really cool, yeah. So we got them. And then there's also the standard method 3, which is your earth loop impedance, ZE. We're not looking for ZS, we're testing the performance of the electrodes. So we're looking at ZE. Now in this installation we have a very standard double drop link earth bar. So we've been playing around with this earlier on for everyone on YouTube land. And what we're going to do is we're going to undo this link and we're going to lift that and drop this out. It's not a problem to the installation because we have an alternative means of earthing which we can use while we're doing the testing.
And what is that? Just for
so this is just another link to an alternative source of earth, effectively. So what we were doing is we're going to disconnect that in a minute once we've put all of the leads out. So before we put the leads out, one of the good things to do is, if you have the installation information, always do that. So I actually have the design here, and the design has like information like the copper. It's effectively a 70mm bare conductor. We've used C crimps to connect to, and if we look through,
it's not rods, is it?
It's discs. So we've used discs, the ConduDiscs from Earthing Services, and the figure designed is 1.1 ohms. That's what they designed. We did some earth resistance, soil resistivity testing. That went to inform the designer. They used BS7430, did some software modelling. And now what we're doing is trying to validate to see if it's 1.1 or even better. Henceforth, we changed the rods to the discs to see if we could get a better improvement. So what the first thing we're going to do is we're going to run out the probes, but just for everybody's information here, what we've done is, because I like to do fag packet-esque style, is what we've drawn out is for everyone here is we have a visual representation of the mega. We then have the red lead, which is the current probe, which goes as far away as possible. And then we have the voltage probe or potential probe, and we're going to stick it in the middle to start with. And then what we've done is we drew out a graph, and that will all get recorded, and we'll show you as we go along.
Sure.
So we've already done this once, by the way. We're just doing it.
We'll go run these leads out, and then we'll show you how to get it all. Well, start testing.
Okay. So the first thing you're doing is this is the current probe, and what he's doing is he's just sticking the stake in with that.
Just have these clamps.
Retention clamp, which are great. They really grip. And we just leave that there, and that goes all the way back and along. And then this is obviously past where the earth farm is, and then obviously the discs are further along, so it's a distance away.
Nine discs, haven't we?
9 discs, yeah. And as you can see where some of it's been dug up recently, and their covers just to indicate. But what we also have halfway is this is the potentiometer or the voltage probe, and that's just stuck in. So now we can go get a reading.
Right, so we're back in the switch room now. Paul's just going to show us the lead
So,
process.
Just as per our drawing, the one that goes furthest away is the red or current. And then what we do is we find the hole on the back of the mega, which is the red one there, and that goes in like that. Make sure it goes in all the way. The yellow, the potential, which then goes in where the yellow is for potential. That's a little bit tight, as always. And then what we'll do is we use the green. The green will go down in that, and then that will connect on to our earth terminal. Now what we need to do before we do any of that is find the right spanner. Where's my spanner gone? Oh, there we go. Right, Tesco value, £8. None of your jokers, none of that. Nice little ratchet, good if you've got arthritis, for people like me. And then we just unscrew, take that off, give that a whack.
And that's what's great about these drop link bars, isn't it?
Drop link bars, they're fantastic. First make great devices. So now what we have is effectively the earth conductor off of the rods connected to our mega. We have our mega hanging thanks to Bristol Sparky.
Don't give him any credit.
And here's magnets of doom. I think he just swings from the rafters with these things, to be honest with you. You have these on. So let's get this, hang on. Spin that around so it's a bit easier. There you go, look, it just clamps on. It's great to stop you dropping it. So what we'll do is we'll spin the meg around to RE, and we're going to go to 2-3 probe attachment. Okay, and we'll push the test button. And what this does, injects current down through here, obviously voltage down here, does all the maths, works out all the differences between each one of those 3 points, and will give us a average, which it calculates internally, of 0.68, which is brilliant. So that was actually at, now weirdly enough, not like we've done this before, but if we actually mark this out on a graph of, say, that's resistance in ohms, and then we look at a percentage of the total length of the installation, we've put the potential probe at 50% of the length, which is 0.68.
Hang on.
So what we do is you can do as many of these percentage readings as you can to plot on a graph, and then what we can do is we can take the mean average of that to work out our overall electrode, or we can add them up and work out a mean average using maths. I prefer the rudimentary, just look where the line goes flat and pick a point in between. That's my preferred method. And so what we'll do is we'll go out now, we'll move the potentiometer, a potential probe, or the voltage probe as we should call it, and we'll get some more readings and then build up that profile.
And the reason why Paul's doing this and has done it before is because this is a new-ish electrode installation, and Paul's just monitoring its performance post-installation. So how old is it?
It's about 9 months, but every 4 weeks what we're doing is we're coming out and we're just getting some measurements so I can get an overall average, so that during a 12-month period I can ascertain how well the electrodes are performing, and then when we get onto the clampless test, we'll tell you how we can continue to ongoing measure that in the future. Which
is important. It's very important with, you know, they are in the ground, they are subject to change, they are weird, wonderful beasts for electrodes, aren't they? So you know, you want to be monitoring them, and you want to be, it's not just a stick it in and go. I would really recommend checking it.
What I'll do is, just for everyone at home, if you look in guidance note 3, it is advised in note 2 of table 41.5 that the earth electrode resistance values above 200 may not be stable. Soil conditions change due to factors such as soil drying and freezing. So that 200 ohm value is really important, because what I want is a TT earth farm that is stable. So when we get onto the non-electrode type test and the clampless stakeless test, then we'll see what we're doing and how easy it is to actually ongoing maintain this. So let's go and move.
Yeah, I'm gonna run out here, move these probes around, and then we'll take another couple of readings and compare. I'd say this is about 25.
Average it out there. And what you're doing is obviously you're getting multiple readings, so you can ascertain soil resistivity, how the discs are performing in different points, so you can work out your average.
Right, cool. Let's see what that was.
So we've just moved it 25% or 20 to 30, and the value is, when it's ready, 0.45. That's interesting. That's a really low reading.
Differs from
it differs.
Do you want me to move that again?
Yeah.
Yeah?
Yeah, that's a really good reading though, because that's better than what we did earlier on. What is good, guys? Don't know anymore. Find myself talking to a GoPro that I can barely see.
Just moved it closer to the tarmac, which is where it was when we originally done it.
Okay.
Still in the same sort of 25%.
I think that was where we put it, was really close to the disc.
Yeah.
So that's probably why.
It's interesting to see how
just little bits of soil can affect it. Yeah. There you go. So weirdly enough, that's more like it now. We moved it back a bit, 0.68, 0.66. So it's kind of in line with what we were originally charting. Yeah. So 0.68. So do we want to do the 20 and 10, or do you want, how many more of these would you like to do? Because I think for speed and brevity, I think we've kind of got the gist.
Yes. So what you would normally do, like you say, is you would take several readings at different points. Ideally, with all the time in the world, you'd do them all. We appreciate it's not always that practical, but yeah, you'd get enough so that, like Paul says, you can find a sort of flattening zone which you can then take your average from.
Yep.
Which is exactly what we done this morning, and that's how we ascertained 0.68.
Yeah. So we kind of took it as 0.68 as our average reading, which is great. The drawing on the top is courtesy of Mega and John Ward, yes. Where the green lines are how energy would dissipate or voltage would dissipate through the ground. Spacing is really important, so we've spaced them at 3 meters. I've drawn a very poor Mega in the corner there, but you get the gist. And I wish to God that they call P and I voltage and current, because it's easier for me to do, and it's a disc system. So that's the first test. So let's just say for editing's sake, 0.68, that's what we're declaring as our electrode resistance. Now this is where it gets a bit more difficult. So we've done the earth electrode test. Now we're going to move on to 2, which is the stakeless test or clamp test.
Right, so we're set up for method 2. I'll let Paul talk through the kit, because this is some really cool kit which I understand but don't know enough about to explain, Paul. So what have we got here?
Okay, so what we do is you've got a clamp picture there, and that's purely and simply set up for the voltage clamp and the current clamp.
And these are very similar to traditional CTs, aren't they?
Yeah, they are basic CTs built into the handle. And what you can do is you can let's just clamp onto something. Straight away it'll give you milliamp leakage through whatever you clamp it onto. So it's got that setting just built in. Now if you want to do your stakeless test, okay, which is what it is, stakeless, and you want to do your clamp test, if you look on these bits of kit, there's a little arrow for direction. So what I'm going to do is I want to measure the resistance going down. So I'll put the current clamp, I'll put the voltage one with the arrow, and I'll just put them like that. But one of the differences between this test and the other tests is this test is a sense check. We mentioned earlier on about 200 ohms is a really good sign of anything over 200 ohms is a sign of a potentially unhealthy earth. So what we're going to do is we're going to clamp back down like so, and we're going to tighten that back up. So we now have the installation fully connected on. We've got all the parallel paths, and what we've got is it's picking up leakage at the moment going down to earth. So we've got 150 milliamps leaking from the installation. Now remember, there's a difference between leakage of the installation, protective conductor current, and diverted neutrals. We're not looking for diverted neutrals. The next test, very simply, is the clamp test, and it's called the stakeless test or test method 2. And what you have is you have a voltage clamp and a current clamp, and on them they have a little arrow. And what we're doing is with the arrow facing downwards, because we want to test the earth farm that we've just looked at with our probes. The installation earth bar is now dropped back down. So what we're going to be doing is just measuring the sum total of all resistances. And this is that maintenance sense check to look if your earth farm is healthy or not. So we know that we've got I think was it 0.6 or whatever it was. 0.68, yeah. So that's really good, the resistance of the electrodes. But just general checking the health of the farm. This is a non-intrusive, no live working, very safe, easy way of doing it. Just put your 2 clamps on, stick it to RE, stick it to 2 clamp method, push the test button, and this will do its thing. It will inject current, inject voltage in a very similar manner, work out all the clever mathematics. We've done the test. It's 1.6 ohms, which is really, really good reading. So that passes. Now, if I ask my maintenance guys to come along here and they got 290 ohms, it's a phone call. There might be something wrong. Let's go and inspect some joints, inspect connections. Really simple, non-intrusive way. Hats off to the Mega guys. And as a Brucey bonus for the Mega stuff, if we look at the Mega stuff and we unplug the voltage lead, what we then have, if we set it to clamp mode, is we actually have an earth leakage meter. So
real smart, and I love, like you say, non-intrusive. You can come, clamp them in, you haven't got to take anything apart, any live works or anything like that. And while it's not a foolproof method, it's great for, like you say, seeing the state that it's in just then. And then
it's a safe system of work method. So you imagine this was a TNCS installation, and imagine we had, say, 40 or 50 amps, because I've seen that a lot. You have 40 or 50 amps and you undo that and you open it, there's a potential for an arc flash there. So one of the things that we recommend strongly, and this is in every voluntary role I do, I always recommend that electricians use a current clamp meter, whatever type you have, and just check for the presence of energy. The higher the energy, the higher the risk. The lower the energy, the more control measures you have. For instance, I'm in a room with a rubber mat as one of my control measures. I can use also on this meter, I can plug a probe into here and I can do a touch voltage assessment by using that button as well. and it can go into milliamps or volts. If you want to see that, we can do that as well.
Yeah, we'll do that.
Okay, we'll do that at the end.
So yeah, we've done the clamp method. We ascertained that it was 2.68.
Yep.
We also did it with the main earth disconnected, and it was 82.7 ohms. So obviously when you have this connected to all the parallel paths, it's going to pick them up, it's going to raise that resistance, but yeah, without them it's great as well. So yeah, we'll do the traditional method now, which is just a ZE test. So yeah, very, very simple, but we'll show that method too, and then you can sort of see all of the different methods, how they differ, and the best one definitely is obviously the probe testing, isn't it? It's the most realistic, the most foolproof. So before we do the third method, we're going to do touch voltages now. The reason why that's important is because we are going to be disconnecting the main earth from the rest of the installation to carry out the third method, the ZE test. So before we do that, we just want to make sure that there's no dangerous touch voltages, which Paul's going to demonstrate here.
Okay, so when you switch on your Mega, you put it to voltage. Okay, now you can use the red lead or this super duper lead with the button in it, and effectively anything below 10 volts is not connected to anything, so it's not going to give you a reading. There's a little button here with the human standing on the ground, and what that does is you push that button and you basically take your probe, you place it on the copper, and it will say nothing. You then push the button and you just verify that that is the case, and at the moment there's nothing. But on this Mega there's a really good setting here where if you just push the arrows and it goes to millivolts, and you can then look at millivolts. And that is absolutely microcosmic levels of voltage as sine waves go up and down. Obviously we're near a railway, but yeah, and some places you can put that on and it will go up. Now if you want to prove this setting, one of the really simple ways of proving this setting is get your extension plug out, your extension plug, your 3-plug connector. You can disconnect that, and what you can do is you can just go to a plug and plug in to the line. Now plug that into a 240 source, push the button, it will come up as 240. That's one way of checking it. If you're using the red probe and you just want a little bit more assurance and you've got a socket near you, I don't have a socket near me, so forgive me, you can plug the neutral part in, plug it into your socket, go along with your probe, and you've got a neutral reference to give you a better accurate reading as well.
So without that, it will use a capacitor,
right? Inside, yeah.
Yeah, and that method you're obviously using a neutral, which is a great.
Yeah,
reference.
so that's obviously not part of the 3 earth leakage methods, but it's just some really handy knowledge to know, because to be honest with you, the Mega MFTs, they are, as far as I'm concerned, they're the best on these, and Chauvin Arnoux are the best on the market, without a doubt. Right, so where were we?
Yeah, ZE. So now we know we can safely disconnect this, which I'll jump on now with Paul's very good
Tesco's 8 quid
for a set as well.
That's no detriment to load out, which I strongly recommend and support. So we're going to clip on the electrode. So this is ZE. There's 2 types of earth loop impedance. Obviously one is ZS, which is the sum total of impedances at any one point, or resistances, henceforth the term impedance. We're now looking for live to protective earth, and we're just going to go for a standard ZS reading. I don't really want a 3-lead method. I'm going for a 2-lead high, and on this installation I have controlled the installation, so we've got this box open for a reason. This is an RCB. It's over 100 amps, so it's an RCB. So you have an MCB and an RCB bolt-on, Dopka. Very good. It's a Type A main switch, and what we're going to do is, so that we don't trip out the RCD and disrupt the whole building, we're just going to go off the bottom of the tails for the purpose of this experiment. Push the button. 1.71 ohms, 134 amp PFCCs. Go on L2. I've switched off the auto test feature. I like the manual.
Yeah.
1.80. L3.
Which is nice, isn't it? All things considered.
1.71. So a bit of a vary there, really. L2 was the highest, so that would be declared as your ZE and also your PFC. Now we're not going to do it here, but obviously we can do the same 2 probe test between L1 and an N, L2 and N, and that will be our PSCC, and whichever is the highest fault current level is what I would declare as the highest fault current within the installation. But the one thing that's really interesting about the ZE is this. It's the 1.35 amps, okay? So under fault conditions, what's the maximum breaker that would disconnect with 135 amps? Maybe a C-type 10 amp?
Yeah.
So realistically, automatic disconnection supply is only limited to C-type 10 amps, which is why we use RCDs on a TT. Because we can't guarantee a low impedance, so we have to use RCDs as additional protection or fault protection. Henceforth, we hope, in the event of an overcurrent, that the earth leakage part of the system will trip out and still give us ADS. And that's your third one, and that's the one that everyone goes to straight away.
Yeah,
but if you have an earth electrode, you can kind of start to understand the behaviours of the soil and the electrode under test. It's a fascinating thing, and then you end up with these sorts of charts. And just for everyone viewing, when you come closer, the cable that goes out of the switch room is insulated.
Yes, that was.
And that is why the impedance is higher there, because when we put the probe in there, it was conducting voltage into an insulated piece of cable until it got to there where it became bare.
And that was the closest we were back here, so it should be the lowest, but because the cable was insulated at that point, it had to double back a further route, obviously, you know, a higher resistance, and then make its way back, which is hence why it was higher, which was, yeah, crazy. It's real world influence, isn't it?
It's an interesting system to work on. I like obviously TT installations. I think they're all right. I think we need to get better at earthing, because obviously there's going to be more foundation earthing coming in the wiring regulations anyway. So, but yeah, other than that, that's basically your three methods, and a bit about touch voltage, and
yeah,
that's it really.
Thanks for having me, mate, and showing me this morning. So I've been here with a couple of other guys, Paul's shown us, but yeah, I just wanted to jump on and show you guys as well, because I've learned a lot today, and yeah, hopefully you guys have learned something, or you know, a tip or anything, even that tip with the Mega, which I know a lot of people today didn't know, I didn't know, but yeah, hopefully you found it informative. I'll catch up with you guys on the way home, and yeah, thanks for your time, Paul, I really appreciate it. So there you have it, guys, that is it for today's video. Hopefully you found it helpful, you might have learned something. I certainly have. Really grateful to Paul for just sharing that knowledge, really. That's what it's all about at the end of the day. I've never really done much earth electrode testing, not at college for sure. I've looked into it out of interest, but yeah, never really done it. So it was good for me to get shown all of the methods, all of the bit kit, and yeah, have a nice sort of real world test environment to do it all in. But yeah, thanks to Paul for that. I'll put Paul's links below to the E5 group and all the great stuff they do. You should know who they are, but if you don't, they are great for the industry. They do loads of educational stuff, all non-for-profit. So yeah, make sure you check that out. If you haven't already as well, please like, subscribe, hit that bell button. It really supports the channel, but also if you like the content and stuff like that, you just won't miss any. And check out Loadout too. Loadout's my tool shop, loads of tools for technical trades. So yeah, I'll put the link to that below too. Thanks for watching, guys. I'll catch you on the next one.